Today I will talk about the ordered Probit and the ordered Logit models. The overview is very simple. I will first talk about the ordered outcome dependent variables, and I will give you a few examples, and then I will talk about the functional forms for the ordered Probit and Logit models, and I will also discuss how to interpret the coefficients and the marginal effects. So here are a few examples of ordered outcome dependent variables. The most common ones are rating systems, where you could have poor, fair, good, and excellent. They also come a lot in surveys, in opinion surveys, where people are asked about a statement and they need to say strongly agree, neutral, disagree, or strongly disagree. Then we have employment status, where you could be unemployed, part-time, and full-time. That's an increasing level of involvement with the job. And then we could have rankings, senior, junior, sophomore, and freshman. These are rankings in colleges in the US. Next, we could have grades. A is the highest in the US, B, C, D, and E. Or we could have bond ratings, AAA, AA, A, B, and so on. So notice that in all these cases, we have the dependent variable would be an ordered one. It will be categorical, it won't be a number, but it will be ordered. You can definitely arrange them from the highest to the lowest using certain criteria. And the highest could be strongly agree, or you may decide to model the strongly disagree as the highest outcome. Now, one very important thing is that because these variables, the dependent variable would be a ranking, we typically would need to provide it a code or a number, because the statistical software needs to know how to estimate these and which one is higher than which one, because you may know that A is higher than B, higher than C, and so on, but the software wouldn't know that. So we typically code the dependent variable as 0, 1, 2, 3, 4, or 1, 2, 3, 4, and so on. But the numbers don't mean anything, because the difference between the first and second outcome may not be the same as the difference between the second and third outcome, and so on. So for example, where you have opinion surveys, the difference between strongly agree and agree may be very small, but between agree and neutral may be much larger, and so on, just as a hypothesis. So again, when you collect data like that, number your dependent variable outcomes, and we would need to use specialized models with this kind of variable. So here are the equations for the ordered Probit and Logit models. The dependent variable would be a single latent variable y star. If we put the star next to a variable, which means that it is unobservable, and we only know when it crosses a threshold. So here we have an equation where we have yi star right here equals x prime beta plus u. So this is a typical part. This is the atypical part, where we don't observe the variable itself, like we don't observe how you feel about the statement. We only observe the 5 categories of strongly agree, neutral, disagree, and strongly disagree. So in this case, we have a latent continuous variable, which would be formed into 5 groups with 4 thresholds, and these are the cutoff points between the different 5 categories. So this alpha would be those thresholds. So in this case, we would have yi equals j if the underlying latent variable falls between the 2 thresholds. So in the case of the opinion surveys, if it's if you're on this agree spectrum of the range, then you could be either in the strongly agree, then if you pass the threshold, you could be in the agree. If you pass that threshold, you will be in the neutral, and so on. So with 5 categories, 4 thresholds. And the probability that observation I would select an alternative J would be Pij, that would be the probability of I selecting J, would be equal to probability of Yi equals J, and that's the same as the probability of this latent variable falling between these two thresholds parameters. And this also simplifies as the difference between these two f functions. So for the ordered logit model, the f function would be the logistic CDF, which is listed here, and we talked about this before in the simple Probit and Logit models. And for the ordered Probit model, the f would be the standard normal CDF. So one of the trademarks of the ordered models would be that if you have an ordered Probit and Logit models that has J alternatives, they will have one set of coefficients, but they will have J minus 1 intercepts that represent these alphas, the cutoff points. With 5 categories, you will have 4 intercepts. With 3 categories, you will have 2 intercepts, and so on. So if you look at the table in a published paper and you don't recognize which model they have used, and if you see intercept number 1, number 2, number 3, that's a clue that they have estimated an ordered Probit or Logit model. Another interesting thing about these ordered models is that if you have J alternatives, you will also have J sets of marginal effects that we can calculate. So the interpretation of the coefficients would be the sign of the parameter shows whether the latent variable y star increases with the regressor. And the magnitude of the coefficients will be different by a scale factor between the Probit and the Logit model. So again, when you look at results, you will say more likely or less likely, and you would interpret that rather than on a particular outcome, you would say that's more likely to be in the higher categories versus the lower categories. And I will give you an example later on in the next video. For the marginal effects of an increase in a regressor XR on the probability of selecting alternative J would be this expression here, and when we take derivatives, we would have this would be the coefficient that we have estimated, and these would be expressions that would also include the x variables and values. So one interesting thing is that the marginal effects of each variable on the different alternatives would sum up to 0, because if some outcomes are more likely, others would be less likely to get back to the baseline. And the interpretation for the marginal effects would be that each unit increase in the independent variable increases or decreases the probability of selecting alternative J by the marginal effect expressed as a %. So that was a quick overview of the models. Next, please watch the examples and then how to do this with different software programs. Thank you for watching.